Okay, so let me increase this font size. Yes. Okay. Yes. So hello, Rati. We are reading this paper, self-supervised, semi-supervised learning, right? So as this term suggests, that self-supervised, it is a combination of self-supervised and semi-supervised learning. It means it is combining self-supervised concept with a semi-supervised concept. What is self-supervised concept? Self-supervised concept, actually, why we need self-supervised concept first? Because we know that producing new data set for each new task is a very expensive. If we want to produce a new data set for a new task, then we have to pay more, uh, we have to use more expenses also. So this is one reason. Another reason might be some areas like medical field. If we talk about medical field, so there are lack of unlabeled data. There is hard to obtain this annotation on this kind of data. And also there is why we are also using the self supervision, because one of the reason is this availability of vast number of unbiased images or videos, because a lot of videos are unlabeled and images are unlabeled. You can find so much videos on YouTube that you can say, okay, these are, we can have a number of images out of that videos, or we can also use that videos for our learning tasks. So this is like a number of unlabeled data we have. And for that unlabeled data, annotation is very hard. So in self supervision, it is learning its label itself. So what is happening in this? It is learning its label itself. For example, let's say one example we have, Elon Musk is an entrepreneur, let's say. So you have a huge amount of data in your Wikipedia or somewhere else, and once you are writing this Elon Musk is a, then it means is a what? So it will this is an unlabeled data set, and label, what will be the label here? Label will be entrepreneur, right? So this label machine is automatically learning from itself, from this unlabeled text available on various sources that is available online. So this is about self supervised. It means it is learning its label itself. Another concept is semi supervised. Okay, so semi supervised means you are using, because this is a semi supervised concept, is between supervised and unsupervised concept. So that means you are using labeled as well as unlabeled data set for your training purpose. What happened in supervised learning? We gave this labeled data for training purpose and unlabeled data for testing purpose. And what happened in unsupervised learning? You are having unlabeled data set. You are and based on some similarity, based on some features, color, and other things, you are just making their group. That is clustering, you can say, uh, dimensional reduction, you can say. So that is completely unsupervised. That means there is no label for this unsupervised. The semi supervised is, and somehow between these both algorithms, it means for training purpose you have a labeled and you have unlabeled data set. So let's start this paper, because this is just a brief idea how both the algorithm are merging in this paper. So this paper is proposed to tackle the problem of self semi-supervised learning of image classifier. So there is a problem in semi-supervised learning of image classifier. So for this, to tackle this problem, it is using this. Okay, so the main thing is here, in this approach, they demonstrate the effectiveness of these method that they have proposed in comparison to both carefully and tune baseline and existing semi-supervised learning methods, right? So then they also have so that this proposed approach of SL4, that means this self-supervised and semi-supervised thing, as S4L we are calling it. So S4L and existing semi-supervised method can be jointly uh, trained, yielding a new state-of-the-art results on this ILS VRC 2020 dataset with 10% of level, and 10% of level is very uh, less number of level data set, and it have this ILS VRC data set. So in introduction they are saying that number of work related work have been done in the field of computer vision, because once we are talking about image we are talking about computer vision. So a lot of work already have done, and how more other author trying to tackle some of the problem related to this, not exactly this, but some of the problem like this image recognition problem, this object detection problem, the semantic segmentation problem. So there are a number of problems they are trying to tackle in the field of this computer vision. And also it's like after working so much on this kind of thing, there is some kind of problem in that. So the problem is like there is this applicability of such system is typically limited in scope. So this is bound to a scope by the data set, because it depend on data set only. So other work also have done to tackle this problem. That problem is in this previous task. So other applications are concerned with visual categories uh, on this some of the standard data set. So here they are showing that there is an important research challenge to design a learning approach that can successfully learn to recognize new concept by leveraging only a small amount of labeled examples. So this is for if you have a small amount of label, not have a large amount of labels for your, in your data set. So this is for that only. Now the next thing is after that some of the research also showing that that concept of self-supervised learning used, how they self-supervised learning used for other tasks. So this paper of self-supervised learning technique define pretext tasks which can be formulated using only a labeled data. So here they are saying that this pretext self-supervised pretext task. What is pretext task? In previous lecture I have in previous video I have explained that pretext about the pretext task. It means if you don't have much images, so like you have one image of this say cat. So and you don't have label for that. So what you will do for that this image in pretext task, you just use a number of this transformation operation. It means you are just doing rotation task over the images, and then you are saying okay this image belongs to this class. So here task in pretext task using self-supervised learning was to find the angle, how much angle of this image is rotated. So with what angle this image rotated. So you what you are doing, you don't have labels, but still you are making number of image out of doing some of the rotation over that images, and then you are finding that things okay this the image is 360-degree rotated, this image is 270-degree rotated, this image is 180-degree rotated, or somewhat else, right? So this is a pretext task they are explaining here. And then they are saying that these kind of algorithm pretext task is using for this downstream task. What is downstream task? Downstream task is once you have a model ready, like pre-training pre-trained model you have, then you are using for different purpose. So that is your downstream tasks, like image recognition task. So this is about still they have done lot of work, like what I have said, 0 degree, 90 degree, 270 degree. So this is a pretext task. So here, is after doing such an efforts in this field, still there is some kind of problem. So they are saying that despite of demonstrating encouraging results, purely self-supervised technique learn visual representation that are significantly inferior to those delivered to fully supervised technique. So here, this limitation is for this limitation is their practical application is limited to as of at self-supervised alone is insufficient. If we are once we are doing the self supervision, but still this is uh, limited because uh, there is insufficient task it can have. So right, so after that, for tackling this problem of insufficient, so they have proposed that self-supervised learning technique that could dramatically benefits from the small amount of labeled example. So you don't have much label example, you have small amount of labels. So in that way, very small amount of label you are using, like an ILS or ILS VRC data set of 2012 2010, it have 10% of label. So they are using 10% of label, it means very less example labels. uh, yes. So right, so this is about what so they are calling this framework, that framework they have designed, design is S4L, means for the topic we have discussed, self supervised, semi supervised learning, right? And also they have used for their purpose, they have used this data set of ILS BRC that also explained. So further experiment have done on uh, this SVL4 method, and done from some regularization method used for this to regularize that things. So then they have provided some data. So their it shows that the main contribution is like new technique, that is semi supervised learning with natural images that that leverage that recent advances in self supervised representation. So this is first uh, contribution of this paper, and another contribution is proposed methodology, proposed this technology techniques that outperform other baselines with known unlabeled data. So this is one more their contribution. Another contribution is about that combining their SLC S4L method with existing semi-supervised technique. So this is one more contribution of this paper. So we'll see all the contribution in deep in next paragraph. So some of the related work is like a lot of work already have done. So some of the related work is like semi supervised learning. So in the field of semi supervised learning, uh, most of the work have related to say like that's you have a label, some labeled, some unlabeled data for your training purpose. So this kind of methodology applied for various tasks. So here this is showing that lot of tasks have done using this semi supervised learning. After that some they have shown that uh, because in the field of the semi supervised learning, number of algorithms also used, that paper have attached here, and this paper have evaluated small scale data set like cipher 10, the SVHN, and this IRS and BRC data set also. So a lot of data set have been used for used for this task. Right. So another thing is, yeah, yes. That means they are working on a small data set, semi supervised learning. And about self-supervised learning is making their label by itself. So self-supervised learning is general learning framework that relies on pretext task. That pretext that already have explained, like rotating an image, because image don't have labels, so it is like rotating that image into different angle and then finding that angles. So this, so other lot of work have been done on this also. So let's come to what this paper propose. This paper proposes SL4 technique, and this technique first provide a general description of this the thing, like what they are using. Formally they are assuming this unlabeled data generator using distribution p of x comma y over images and labels, right? So this is for a joint distribution. So once they are generating this joint distribution over images and labels, then the learning algorithm has access to a label training set, DL. So this DL is for labeled training set, and which is sampled IID. IID is for identical and independent distribution. Out of that distribution we are talking about, from this joint distribution. Yes, yes, we have that independent and identical distribution over this in that probability functions, right? That joint distribution and these things we have already seen in previous lectures. Yes. So labeled data we are calling it as DL, and unlabeled data they are calling it as DU, and both they are using as training set, because here they are saying that labeled data set is also using for training and unlabeled is also using for training. So which is sampled independently and identically distributed from the marginal distribution. So here what distribution they are using? They're using marginal distribution over this px. So this semi supervised, so here uh, this symbols we are using, these symbols we are using just for the sake of this semi supervised task. We are till that we are not using this self supervised, we are using semi supervised task here. So the semi supervised method we consider this paper is, in this paper have learning objective with the following terms. So what learning is happening, we are minimizing this theta with respect to this labeled data set as well as unlabeled data set for this training, and trying to find the loss over this labeled also and unlabeled, both are in separate terms, and then combining both that theta, that loss into a generalized loss. So L1, the L1 or L and LU is cross entropy loss, using for this labeled images and for unlabeled images. So cross entropy loss we are using here for classification. And what else? Yes. Right. So this is method, and okay. So after that, this w is non-negative scalar weight, and theta is the parameter for model f theta dot. So it's like losses, unsupervised loss are computed in that term. After that, once this self-supervised, this semi-supervised task started here, and then there is merges a concept of self-supervised with semi-supervised learning. So here, and they present their approach in the context of multi-class image classification, even though it can be easily generalized to some scenarios, such as you can say dense image segmentation, or or what else you can say, different image segmentation tasks. So yes, so for that, if we go mathematically, so they are using this supervised mini batch x1 l1 for this training data set. That is a subset of this training data set. And updating this parameter theta, that is our learning rate, not yes, that is a learning rate. And they have also made mini batches of data. So mini batches means it is a optimization technique, mini batch of credit decision to use na, is that kind of so we made batches, small batches of all complete data set for supervised as well as for unsupervised. So because supervised have labels also, so we are taking L1 and Y1 subset of D1, and unsupervised don't have labels, that's why it is using XU subset of DU, and that can be arbitrarily chosen. So here it's like simple things happening. Then then they are choosing whether to include mini batch XL into the self supervised loss or not. So if they are applying it, then it is, and they are taking L self to the union of XU and XL. So let's go beyond. And for this, as we have seen, that pretext task is also happening. So just a minute. Okay, so S4L rotation is also happening here. That means uh, we have discussed about this pretext task, right? So like pretext, in pretext task, this we already have discussed 0 degree 90 degree doing some rotation. So then S4L rotation is happening here, as four kind of rotation is happening here. This is kind of augmentation of images, like you are increasing number of images. You have one image and you are making uh, three more images out of that image. Or if you are including zero angle as well, so you can say this is a similar image, so that you can say okay, four more images you are augmenting here. So XR is the image, and X rotated by R angle. So this image is rotated by with some angle. Angle should be selected out of this. So okay, so now it becomes, because there is four angles, so now it becomes a four class classification problem, right? So this becomes a four class classification. And then yes, and then just a minute, गेट लगा के जाना. Yeah, sorry to disturb. Yes, so then we follow a recommendation from this paper. They have used this paper, and then have done some optimization technique, because for this need to use some optimization steps. So they have used some optimization step on some mini batch images, and then they have applied this self supervision loss to the labeled images in the each mini batch. Since they have proposed rotated supervised images, because they are using this rotated supervised image, so they suggest to apply a classification loss to this images. So here they are calculating this classification loss, because four classes they have now. So for that four classes, they are finding how much loss they are getting, which means how loss can be calculated here if that image not belongs to correct rotation. So then loss will be calculated here. Okay, so this is same thing that I have said is described here when a small amount of labeled images are available. Right. So there is one more thing as for an exemplar. What is this thing? So The idea of exemplar self-supervision is to learn a visual representation that is invariant to a wide range of image transformation. So exemplar means kind of uh, that are giving examples, right? It means if you are having one example, then you are creating number of example by doing some kind of image transformation, then that is called exemplar. As far I can see, might be wrong, we can see. So idea of exemplar self supervision is to learn a visual representation. So this exemplar is learning a visual representation that is invariant to a wide range of image transformation, right? So especially they use in inception cropping, random horizontal mirroring, and HSV space color randomization to produce 8 different instances of each image and mini batch. Okay, so how they are doing, what transformation they are doing here. So this is about that. And then implement LU as batch hard triple loss. So what is triplet loss here? Simply we can say you have a image of let's say this is, yeah, uh, just let me raise this. Triplet loss is like you have a positive image, you have a negative image, and you have a image, and you are finding that difference, because similarity you are finding between that image, because that is not labeled now. So once the image is not labeled, let's say this is Rati, and this is Rati's photo from database, and yes, and and one more photo is for me, and this is my photo, right? So triplet loss is, this is negative image because this is this is your actual image, and this is your positive image that is similar to, because this is not labeled now. That's why how you can find similarity based on some similarity functions that we have seen in one sort zero sort learning. So where we have a less example, and we were finding that's cosine similarity and other similarity, and this is a negative example. So triplet loss, find the loss between all three with respect to positive and negative. Well, it compare this image with this and this image with this, and then it find the similarity loss. So I think that is would you like to add something here? Yeah, yeah. All right. So uh, here after that doing this finding that triplet loss with some soft margin, some transformation of the same image to have similar representation, and then encourages transformation of different images to have different diverse representations. So similarly to the rotation self-supervision case, LU is an applied to the 8 instances. All that 8 images we have used, so it apply for that 8 instances of each image. So how that 8 instances is created? By using the transformation that we have discussed here. Not only the rotation one, similar some of from rotation and some of from this place, this cropping, random horizontal mirroring, and HSV space color randomization. Yes, these are also augmentation techniques. So that's why it is creating 8 instances of each image, 4 instances of rotation, and other is using that other different techniques. So same then after that they have compared their result with baseline. So there is some semi supervised baseline. Okay, so what are that semi supervised baselines? um, yes, so they have compared this their technique to several leading semi supervised algorithms that are not based on the self supervised objective. So yes, so they have proposed their objective is applicable for semi-supervised learning method as well, and where L loss LU is the standard semi-supervised loss. So how it is happening? So there is a concept of virtual adversarial training for this purpose, for this objective. So the idea is of this virtual adversarial training is to making the prediction labels robust around input data points against local perturbation. So some kind of local perturbation is happening in that augmentation, means some kind of noise or some kind of uh, robustness. It means some kind of error is adding in that image, so it should be robust to that. Yes, yes. Yes, yes. So it approximates the maximum changes in the prediction with an EVAT vicinity of labeled data points, where EVAT is a hyperparameters, concretely the VAT loss for a model F theta. So this is where to find this virtual adversarial training loss, bat, and that is called bat loss. So here this is a first they are finding the scale divergence between this two terms f theta and f theta plus some kind of perturbation. The delta theta is like adding something. So and then they are how they are finding this perturbation also. I think this is for computing delta x directly. Okay, so what is this? Computing delta x directly is not trackable, so it can be efficiently approximate the cost of extra forward and backward pass for the optimization. Yes, so this is for like forward and backward optimization step using for that. Okay, and then there is a concept of conditional entropy minimization. So conditional entropy minimization is calling they're calling it as Antmin. So this work under the assumption that unlabeled data indeed has one of the classes that we are training on. So what does it mean? What would they like to say here? This work under the assumption that unlabeled data indeed has one of the class that they are training on. It means they have one class they are training on, and even when the particular class is not known during training, means they have two classes, one is known, one is not known. So it add a loss for unlabeled data, and then minimized encourages the model to make a confident prediction on unlabeled data, and especially the conditional entropy minimization loss for a model f theta treating f theta as a conditional distribution of labels over images. So this is a conditional entropy minimization and loss. So this is log loss, and then what else? So for this you have to go this concept if you don't know about this conditional entropy minimization. So I think better to go to this entropy minimization technique, and then you'll understand in reference to this supervised and unsupervised terms. So they are saying that alone the adment loss is not useful in the context of deep neural network, because the model can easily become extremely confident by increasing the weight of the last layer. And one more thing is like one way to resolve this is to encourage the model prediction to a locally lipstick. We have seen in machine learning one this locally lipstick rule with the VAT and us. So there, this is well explained in this paper. So there are for means therefore we sorry, therefore they only consider VAT and admin combined loss. So they are not taking only a single loss, neither this VAT nor this ENT mean, but they are combining this VAT and admin loss, admin loss together. So this can be loss over unlabeled images using both loss. All right, so here after that this is a pseudo labels, like how they label that. So a simple approach, and first they train a model only on labeled data set, then make prediction on unlabeled data set. This is a pseudo label, then enlarge their training set with the predicted class of unlabeled data, and then point those prediction are confident past some threshold of confidence. So then they are finding some confidence over that things, and then retraining the model with this enlarged label data set, that bigger one data set, because for a small data set they have done this thing, and then they are doing it for large data. So while so that the simple two moon data set, pseudo level fails to learn a good model. So in many real data set, this approach does show meaningful gain. So this is like still there is some kind of problem. So what are result of their experiment? Result of the experiment is shown in this part, and there also they have explained like what kind of split they have used. So they have used this ILS VRC data set, and they are saying that test set is not available for this data set. So that's why and then what they are doing, and also number from the validation set are usually reported in the literature. So because they don't have test sets, so they are using this validation set, uh, using that validation set they perform some kind of hyperparameter selection for all models, doing some kind of a step function and learning rate and epoch things. So these are hyperparameters, so they have selected that things with some extent, and then also they have this splitted that data set is, into training and validation. So in training email data set, it contains 12 this, how much is this, 1.2 million I think, yes, not uh, yes, 12 million, and this is point zero 0.05 million for validation. So 12 million for this training, and 0.05 million for this validation images. So they have retrained the model using the best hyperparameters. So for that purpose they all might have done this hyperparameter tuning. Yes, and then they are saying that label is not available. So what they have done for they have followed the standard practice of this paper, how these two paper done these things. If labels are not available, or with a small label data set or label data set, so and then perform experiment where class label example are available for only for 10% of data set. So this is like their experiment, and plain supervised learning. There's one more concept of called plain supervised learning. So let's see this also. So whenever new method are introduced, it is crucial to compare them against a solid baseline of existing methods. So the simplest baseline to which any semi-supervised learning method should be compared to is training a plain supervised model on the available label data set. What uh, train on training a plain supervised model on available label data set. This is what this line would like to say. Okay, So in this regard also, like plain supervised learning, number of literature task already have, number of work already have done. So like this paper, Oliver et al. Discovered that a reported baseline trend on labeled example alone are unfairly weak, and perhaps given that there is not a strong community behind this turning those baselines, so they provide a strong baseline only of this SVHN and cipher time. So this is just about like the also have this same things, 10% of ILS VRC 12 T20 2012 data set with some kind of hyperparameter tunings and with a learning some kind of learning rate. So this they have shown, and different learning rates scheduled spanning between this 330 to 500 epochs they have used. So this is like the setting of a model. So yes, so this is a model, a pre-trained model over this 50 ResNet 50, ResNet 34, ResNet 34, ResNet 80 they have used for this purpose, and then they have find half, double, triple, quadratic with variant of these. Okay. So this about and also this was one experiment. Some more experiment have done by changing the this hyperparameters and epochs and ResNet model, means pre-trained models. So here they are saying that only, and then they have checked their accuracies. After that also they have also performed one more experiment where they have used this unmodified ResNet 50 V2 model trained with this weight decay of 10 power minus 2 for this 1000 epoch. So they are increasing epoch size one by one, and then before that epoch highest epoch size was 200 epoch, and before that it was less than this. Now epoch size increased to 1000. Yes, and then they have find some accuracy over that. So okay, so this is also this is done on 1% of uh, ILSV data set. This baseline have performed. Another yes, yeah, another using this only slightly alter training procedure. So our baseline model achieved. हाँ हाँ खुला है, एक मिनट, जस्ट अ मिनट, खुला है, कौन है? मैं कह रहा था कि वो कास्टिक सोडा पैकेट आपके पास है क्या? कास्टिक सोडा क्या होता है? एक फ्रिज पे पैकेट रखा हुआ था कास्टिक सोडा, ब्रेन, अरे एक मिनट, मेरी मीटिंग चल रही है, रिकॉर्डिंग चल रही है। कास्टिक सोडा नहीं है हमारे पास किसी टाइप का। ड्रेन क्लीनर करके था पैकेट फ्रिज में। I don't have idea. Yes, so sorry for interruption, and you are here using this only slightly. It means they are one by one they are using they are increasing their epoch size and their learning rate, their hyperparameter setting, and some kind of data set change in this ILSP data set, some percentage of labeled with unlabeled, and then they are checking one by one, they are checking their accuracy. So let's check it for with this table. So this table is showing that ILSVRC 2012 labels with 10% label means it have 128 image per class, and 1% means 13 image per class. So when perform some experiment over this, it's shown that their S4L rotation performed with a higher accuracy, and also there are S4L explainer exemplar performing higher accuracy as compared to other methods, and also they have this what yes, so these are like some kind of different setting experiment. So yeah, this is about results, and there is some kind of semi-supervised baseline also. So also for this semi-supervised uh, semi-supervised baseline, so they have trained this semi-supervised baseline model using pseudo level VAT and VAT plus ENT min, and to the best of their knowledge, what they are saying, okay, so to the best of their knowledge, they present the first evaluation of these techniques to it means this is like first technique for this working on this ILS VRC data set. Yes, so for this purpose also semi supervised baseline also they have taken number of a method with VAT min, and with uh, different uh, rate, and then they are finding different losses over there. And then there is some semi super self supervised baseline also, and in the self supervised baseline we have seen like this self sub plus fine tune. So these are like result of evaluating with both 10% and 1% or data set that we have seen in the table, that 10 with 10% and with 1%. Yes, so what else? So that this thing we need to note one more thing, as like while their experiment for the linear experiment are similar to those reported in this, they are not directly. So this is due to they are being means this they are want they would like to explain that their results are is somehow similar to this paper, but they have used a different approach. So this in this term this method is different, and they also use this LBFGS while they use this as stochastic gradient descent with the standard augmentations. Furthermore, they have fine-tuned this approach or slightly surpasses the supervised baseline. After that, they have explained this accuracies over this. Yes, so this table is for comparing their MOAM to previous method in literature of this ILS VRC 2012 with 10% of label. So no, again they are saying that their difference model are use different architecture. This all models are using different architecture. So this MOAM is that they have proposed is performing better than other models. This is also they have proposed uh, over this training with all labels, right? So whatever they have proposed is getting a better accuracy than before. Also, here they are showing that all the step intermediate step of getting these accuracies. So it's like first they are rotating that image, and then they are calculating the BAT and ENT min that we already seen what are these with some kind of uh, some kind of hyperparameter change. So hyperparameter setting. So these are like learning rate with decay of 2, learning rate of 0.1, batch size of 0, batch size of 128, and 10 power minus 4. And again training for 200 epochs with linear learning rate. Yes. So they have used the following relative loss of weight: 0.3, 0.7, 0.3, and 0.3 weight. So also and they have also applied this polyic averaging to model parameter by choosing the decay factor such that parameters decay is 50% over each epoch. And then the model obtained after this first step achieve 8.85% top 5 accuracy over this data set. So this is like once. So this we have seen in table also, in short, like accuracy overperforming this different operation. So another step is they have retraining on pseudo labels. So it means they have assigned a pseudo label to the full data set, and then they have done some averaging prediction across 5 crops and 4 rotation of each images. So then we then I mean they then train the same network again in the same exact way. It means just here only one thing is they have assigned pseudo label to the full data set by averaging product predictions across 5 crop and full 4 rotation of each image. So yes, somehow if they are getting some better accuracy than while using this. So here you can say that these are 4 different operation they have performed: S4L rotation, S4L rotation over short images, and this is like using logistic regression in this purpose. So yes, so places 205 learning curve of logistic regression on top of the okay, what is this image about? So this image is about places 205 learning curve of logistic regression on top of the feature learned by the pre-training and self-supervised versus S4L rotation model on ILS BRC 2012. The significant faster convergence, I mean it's long training versus short one. Faster convergence means long to short, such as a more easily separable features are learned. Okay, so here is like okay. So then after doing these two step, and third step they have fine tuning this model, and the final model after fine tuning this model, the final model called full achieved 91.23% of top 5 accuracies, which set the new state of the art model. So they have conducted this experiment and reported this performance of MOAM with 100% labels, and table 2 this thing is showing. So MOM achieves a promising result even in the higher data design with 100% labels, outperforming the fully supervised baseline of this 0.87% for top 5 accuracy and 1.6% for top 1 accuracy. So transfer of land representation. So self-supervision method are typically evaluated. I mean, kind of representation, the pretext representation or other representation they have learned, and then using it as transfer learning. So self-supervision method are typically evaluated in terms of how generally useful their learned representation is. So and this is done by treating the learning model as a fixed feature extractor, and the training a linear logistic regression model on the top of the features it extract on different data set. So this is nothing like they are using just representation as a transfer learning. Okay, now now what? Now they have reported some other papers uh, with different accuracies, and that shows that okay, so with the with this paper that's so a very long training a schedule of 520 epoch is required for the linear model to converge using self-supervised representation. This is about the graph we have seen, and so this is about like graph we have seen in here. What graph? I think this graph we have seen. Now now they are talking about this table 2. So they are showing that while using different setting over S4L model, they are getting a different accuracies of 83.3% and an accuracy of 83.1%. So now they have used a validation set. So is a tiny validation set enough? It means they are asking this question, is that enough or not? So yeah, yes, right, for semi-supervised learning task it is happening. So current standard practice in semi-supervised learning is to use a subset of the labels for training on the large data set, but still perform model selection using scores obtained on the full validation set. So it's like a validation set they are using for their validation purpose. I don't think they need to explain this. Like full size means 100% data they are using half. Not full size means they are not using complete data set. So here finally this is about discussion and future work. So in this paper they have bridged the gap between self-supervision method and semi-supervision learning by suggesting a framework of L4L, S4L, this model, and they can which can use to turn any self-supervision method into a semi-supervised learning algorithm. So this is they can remember this thing. They have proposed a framework which can be used to turn any self-supervision method into a semi-supervised learning algorithm. Self-supervised to semi-supervised, and then instituted two method, and they proposed two method S4L rotation with exemplar, and they have shown that they perform completely to method from the semi-supervised literature on the challenging data set, and their model performed well on that. So there they are talking about their accuracy of performing their model. So in future they are hoping that this work inspire other researchers in the field of self-supervision to consider extending their method into semi-supervised method using their S4L framework, as well as researchers in the field of semi-supervised learning to take inspiration from the vast amount of recently proposed self-supervision method. So I think most of things we have covered in this. Let me stop this recording.